So in this video, we're going to take more examples about supervised learning. So we're going to take in the classification section, which is predicting diseases, and we're going to take an example of predicting diabetes and predicting cancer, and then we're going to take something called sentiment analysis, and the example that we're going to take is analyzing sentiment through Twitter tweets. And the last example that we're going to take is going to be face mask detector, which means if the person is wearing a mask or not. The first example that we have here is predicting diabetes. Here we have the data of patients with their medical variables, and these are the medical variables. These are called features: BMI, diabetes, pediatric function, age, and then the outcome. Okay, one means yes, he got diabetes. 0 means no, he didn't get diabetes. Let me explain it to you. Here we have the data, okay, and then we're going to feed it to the classifier, to the algorithm, and then the algorithm is going to classify by, let's say, 0, which means no diabetes, these people doesn't have diabetes, and 1, which means yes, these people got diabetes. 0 and 1, yes or no, binary classification. And this is how the data look like, and this data is bunch of numbers and text. It's a simple data, so we're going to use machine learning algorithms. Let's say we're using logistic regression. Okay, this is the name of the problem, and you can check this example in details from this link. You can find these slides on my website, the-mis.org. You can find it there. Okay, so this was example number 1, and this is how the data is going to look like in real life. Okay, next we have predicting cancer. Here we are still have the data in the field of medicine, but previously it was bunch of numbers and text. This time it's images, and there's our brain images. Since the data became complicated, it's no longer a bunch of numbers and text, it's images. Now we're going to jump to deep learning. If you remember, we said whenever one of the main reasons deep learning came into existence, because the data became complicated, which means we have now images. So here we're predicting the brain cancer, and the name of the example is classification of brain tumors from MRI images, and these are the MRI images using something called convolutional neural network. In short, we call it CNN, and CNN is a type of neural network or artificial neural network. We're going to take that in the deep learning course, and this is the link if you want to check more in details. Okay, if you see this small circle area, these are the tumors, and the output is going to be yes, he got brain tumor, no, he didn't get. 0 and 1, or sorry, the opposite. 1 means yes and 0, or whatever, depends. So this is a binary classification. It's still in the field of medicine, and it's still supervised learning, and it's still classification, but here we can see the data is no longer a bunch of numbers and text. Okay, here we have images. Simple data, we can use machine learning. Complicated data, we use deep learning. There are some scenarios we can use also deep learning and simple data, but we'll talk about that later on. And another example do we have here is predict face mask detection. Forget about the region. Face mask detection. Here we can see that it's not an image, it's actually a video. I am giving these examples intentionally because I'm taking it step by step, from simple data to complicated to very complicated data. Here we have a video, and it's a live video, and in that camera we have an application. In that application we have a machine learning model or deep learning model. Here we can train a lot of images of people not wearing mask, and a lot of people are wearing mask. And then here the model is going to detect that no mask, 95.99%. This guy is not wearing a mask, which is, let's say, 0, and this is 97.77% that this guy is wearing mask, which is 1. Binary classification, but this time it's deep learning and we are using the data is video. Alright, next we have sentiment analysis. We are analyzing tweets, Twitter tweets. So let's say I'm working in a company and I just launched a new campaign. Okay, and people are talking about this campaign, and let's say here we can see that we are so happy you found us. Feel free to send a message if you need any help, and let us know when you're building, and there is a smiley emoji. So since there is a word happy and there are no curse words or bad words or negative words, this can be classified as a positive tweet. And if there are like dangerous and ugly and this negative words, we can classify this thing as a negative words. If there are let's say both negative and positive words and it's finding some difficulties, here you can see it's neutral, it's neither a positive or nor negative. These type of things we call the multi-class classification, because we have 0 and 1 and 2, for example. So you don't have a binary. If it was only positive and negative and there was no neutral, then it's a binary classification. And here we can see that we have a text, only a text. Okay, this field is called NLP, which is called natural language. Sorry, it's an N, not an M. Let me write it again. NLP, natural language processing. Natural language processing is a field of machine learning where where our data is going to be only text. Okay, so here we have also a classification problem. And after that, we're going to talk about unsupervised learning, and we're going to talk about it in next video. Thank you so much. See you on the next video. Bye bye.